Hi, my name is Rama. This is my CS 521 final project, the Twin Pharma Telemetry Auditor. In a remote clinical trial, participants wear wearable sensors that record heart rate, blood oxygen saturation, skin temperature, and a voltage that tells you whether the sensor is still attached to the skin. When the sensor falls off or when the wireless signal drops, you get a gap in the data record. Under FDA and ICH regulations, every gap must be documented. The missing values must be filled in with synthetic data, and a qualified reviewer must approve and lock that audit record. This program automates that entire workflow from a single command. Let me start with class file participant timeline.py. So this Python notebook has three cells. The first one is a class definition, which is a participant timeline.py. This file is imported by the main program. It is never run directly. The class is called participant timeline. When you create an instance, you pass a participant ID such as TP001, and the constructor sets four attributes. The two attributes participant ID and synthetic blocks is a list that stores every gap fill episode the program creates. The two private attributes underscore records underscore baseline which stores raw sensor readings, a dictionary, and a dictionary of per channel statistics. There is a wrapper method that that returns a clean string like participant timeline. There is a length methods gives the total record count. The private method compute baseline takes an optional window argument and computes the mean and the standard deviation for heart rate and SpO2 and temperature across the participants' first real readings. The four public methods are add reading, detect dropouts, fill gaps, and get statistics. All of them take arguments and return values and are called from the main program. When I run this cell, it creates the file participant timeline.py in the current folder structure. So now let me walk through the main application program, uh, which is a twin pharma auditor.py. So first of all four required container types are present and used for real clinical purposes. At the top of the file, CSV fields is a tuple of column names, a tuple because it is immutable, and the CSV schema never changes at runtime. In the build timelines, so in the build timelines, I use a set comprehension to collect unique participant IDs. In a dictionary that maps a participant timeline object, and lists are used throughout for records, dropout intervals, etc. Next, the try except else block. So the try except else block in this load sensor data. The try clause opens the file, except clause catches file not found error, the else clause which only runs when no exception was raised. This is a proper try except else, not just try finally. The reviewer console uses a while true loop. So uses a while true loop for the main command dispatch, and for loops are used throughout for iterating over records, participants, and channels. Every command in the reviewer console is dispatched through if else, and the input call inside the while loop is itself is wrapped in a try except clause. If the notebook environment is not interactive, an end of file error is caught and all pending blocks are auto-locked gracefully. The program does not crash. Now let me show the program actually running. So first it generates a sensor data.csv with dummy readings and readings. You can see TP001 has TP001 has one dropout event, 5 synthetic points. TP002 has the same thing. TP003 has 2 dropout events and 6 synthetic points. Uh, then the per participant report prints for each participant, uptime percentage, drop count, etc. details. The cohort summary then rolls everything up, 3 participant, 4 total dropout events. 16 synthetic points and an average uptime of 86.67% across the trial. Then the reviewer console opens. I type view 0 and then lock 0 and then done. So finally the program reports that audit is complete, ledger saved to audit ledger.text. Unit test, the final cell runs 2 unit tests. One is test add reading and another one is test detect dropouts. So the test add reading creates a fresh participant timeline and asserts length of timeline equals 0 before any records are added. It then calls add reading with the same record as a sample. Asserts return value is 1 and length equals 1. It keeps adding more records to confirm the count goes correctly. Test 2 is a test detect dropouts, builds a controlled timeline. Control timeline with 5 normal readings with a range of 5 and 3 dropout readings and 2 recovery readings. And then it calls detect dropouts and asserts exactly 1 dropout event was found. That the reason string equals low adhesion and that the start temperature matches the correct second. Both tests print pass and the final line confirms all tests passed. Thank you for watching this. Have a good day.